Hey guys, welcome back to another Java Bro video. In this video, we're going to cover what optionals are in Java, and I'm sure that by the end of this video, you'll be an optional expert, and that's not optional. Jokes aside, let's first get an idea of what an optional is and where it came from. So where do optionals live? Well, first of all, optional is a class in Java and it lives within the java.util package. As you can see, it's a utility method, and the brilliant thing is it's basically ready to use straight out of the box simply by creating a new instance of the optional class. It was introduced to us in Java 8 and it's had some cool upgrades along the way. The optional class in Java is essentially a way to tell if something is empty or not, or a way to represent an empty state in our code. So now we know that an optional is basically of knowing if something is empty or not, like for a particular object. How do we use it? Well, think of it this way. The optional class wraps around an object and kind of acts like a container. So as you know, for container, it either contains something inside it or it doesn't. So it basically takes your object, puts it in like a nice container. And there are only two possible outcomes, right? It either is empty, your container, or it has something in it. So here's another way of looking at it. Let's say someone hands you this really nice fancy looking sunglasses case, yeah, with Ray-Bans, promised Ray-Bans inside it. You could open this sunglasses and if you're lucky, there you go, you got some nice Ray-Bans. But you couldn't tell from just looking at the sunglasses case, right? You had to open it up to see what was in it. Your other outcome, if you were a bit unlucky, is you would have got an empty case. So this is essentially what an optional is, the sunglasses case, because the sunglasses case houses the glasses or it doesn't. So think of an optional like a container or a glasses case in this example. Right, so enough of me chatting, let's do some programming, because that's what we're here for, right? So let's have a look at how we can create an optional. So I've just got an empty main method over here, and to create an optional, we have to call the class. So if you remember, the class is literally optional, and as you can see, it's in the java.util package. So let's use it there, and you can see it's imported out for us. So literally to create an optional that's empty, so this is the example where the glasses case did not have any glasses in it, we simply put a dot here and we can access these cool utility methods. We're going to use empty, and this is essentially right now an empty optional. Let's store this in a variable. So if we do .var, which will automatically extract this into a variable, you can see that this is actually what an optional looks like as a variable. So let's give this a name. Let's call this empty optional, just like that, right? And you'll see here, to create an optional, we need to wrap around it, exactly like I was trying to explain earlier. It wraps around the type. So let's change this to a string, okay? So let's just say we had a string, but this right here is basically an empty optional of type string. This will make a little bit more sense later on. Let's look at how we create an optional with a value already in it. So we're going to do the same thing. Or let's do it the way we did it before. Let's do optional dot, and instead we're going to use this method here, the optional dot of method. And let's type in sunglasses are present, right? So this is the scenario where you open up your sunglasses case and there are some sunglasses, and let's do .var, and there you go. You can see that it's actually created our optional of string. Let's just change this to sunglasses optional. Let's just do that. Sunglasses optional. If I can spell. There we go. Right, and let's stick this on another line just so you guys can see that a bit clearer. Right, so this is how we create an optional, and let's have a look at what happens if we print out these values. So let's first look at the empty optional and let's run this. As you can see here, it literally prints optional.empty, and let's have a look at what our optional looks like with the sunglasses optional. If we print this out, notice it, we've got optional, and inside these square brackets we've got our value. Now remember, this is an optional, so this isn't actually the string. This is simply the optional which contains something. So this is the container, and it's telling you what's in the container. So this is telling you that your container is empty, which is correct. And this is telling you that there's something in your container, which is sunglasses are present. Now, one rule I'll give you from now is if you're trying to create an empty optional, never, ever, ever equal it to null. Okay? This is bad practice. You should always make it optional of empty. And you can see here, IntelliJ is also giving you that hint. And I'll explain why in a bit, but the whole concept of optional is to kind of go away from the concept of null. Because at the end of the day, null isn't the best looking thing in your code, really, is it? A lot of modern code these days will have nulls and null checks kind of scattered around the place. So always use optional.empty to create an empty optional. Okay. Now you're probably wondering, how do you access this value? Obviously, there's nothing here, but what if we want to get out this string that is inside this container? So how do we kind of like unwrap it? Well, there are several methods that I'm going to show you which do exactly that. But the first one I'm going to show you is actually something you shouldn't use, which is actually provided. So it's a bit funny that it's provided, and that is the .get method. So there is an optional .get method. So if you see here, this is the optional of string, which has our value in it. If we use the .get, if you notice there, let me do that again. You can see here, let me check down another line and type in the E just so you can see that it returns of type string. That's simply because we've provided a string. So by calling the get method, we're unwrapping this and getting the value inside. So now if I print that out, notice we don't have the optional wrapper around it. Now here's the caveat, and this is exactly why, if possible, try to avoid using this get method. What if we did it for the empty optional over here? Well, let's have a look. And let's run this. Right. We got an exception because our empty optional is blank. It's empty. There's nothing in it. So there's nothing to get, which is why we got a no such element exception and got a no value present message there. So that is why we want to avoid using this .get method. Okay. So that's just to show you that this is provided by optional and a way to unwrap it, but it's not the best way to unwrap it. And I'm going to show you the best practices in just a second. So now we've learned the kind of basic inner workings of an optional, but we need to ask ourselves, why does the optional class exist? And what did we do before the optional class did exist, right? Before Java 8, let's say. Well, the truth is we use null everywhere, right? Everywhere we look in our code, there are null checks, there are null pointer checks, and it doesn't look very clean. And we can use optionals to write really lean code, really good looking code that's easier to understand because we have a concept of empty or not empty, right? Let's have a look at an example. Now, this code here is very basic, okay? We have a superhero database class over here, right? And inside this database class, we've just got basically something that will replace a database. So think of this as a database that contains superheroes. Okay, we've got Spider-Man, Batman, Superman. This is just something just to use as an example. And think of this as a repository method. Okay, so usually if you're doing like a Spring Boot application, you would have a repository, and within that repository there would be a method where you can find, or you might have to create a method, for example, yourself, where you can query the database basically with a parameter. So here's a really basic one where all we're doing is we are going to loop through this list and find a superhero that matches the name. So if the user was searching for Spider-Man, we would return this superhero here. So we're essentially allowing the user to search this database by name. Okay, and if we find a match, we will return the superhero, otherwise we'll return null. Okay, fairly straightforward scenario where if the superhero does not exist in a database, we return nothing back. And you'd probably have a service method, okay? And the service method would call the repository. So that's what this is mimicking here, okay? Think of this as our service method, where what we're doing is we're calling the database to find a superhero by name. And this is quite standard code you will see in quite a lot of applications. Just in case you wanted to see, this is the superhero class. It just contains the name and power properties, and some getters and setters and a constructor. We won't really be touching this class, but that's just to show you. So let's just say we were coding away and we wrote some code where we can ask the user for some input and we'll find the superhero by their name, okay? And let's say the user input was Spider-Man. So we can store it in a superhero variable. Great. And now we can print out superhero by name and maybe even use toString, right? Great. Let's click run. So what this will do, this will call our method over here, and this will search in the database to see if that superhero existed. Okay, so let's click run. And there we go. We've got Spider-Man back. Great. That's great. We could even do Batman and get rid of that. And click run. And there we go. We've got Batman back. So we know that our code works. Okay. Now, what if someone was searching for Ant-Man, for example? Well, we got a null pointer. Now, the reason we got a null pointer is because this superhero is null, because our code returns null if there's no match, okay? Which is fine. This is absolutely perfect code. You could write this. This makes sense. But the problem is we're now calling toString on a null object. You can't do that. You can't call toString when there's nothing toString, literally, right? And even if without this, we're getting this. No, not very user friendly, is it? It's not really great as a user to just get null back. So what we would do before Java 8 is most likely do something like this. If superhero by name is not equal to null, then print superhero by name. Otherwise, maybe print superhero does not exist. Okay, and this code is absolutely valid. It does exactly what it needs to, right? If we add the toString at the end and now run this, you can see we now at least get a nice message, right? Now, this is absolutely fine, but you will see these blocks of code everywhere because before Java 8, there was no real way to explain if something is empty or not, okay? This literally will just return that null superhero straight back to our controller or back to the user, right? And then we have to write some logic to handle the case where it's null. And it's not particularly pretty because this doesn't really mean a lot in terms of when you look at it, what is null, why is it null, etc. It's just a null value. It means nothing's there, right? There has to be a better way to do this. And that's what optionals are here to fix. So here's another rule, okay? Optionals need to be used as return types. So optionals, we shouldn't really use them for properties or take them in as parameters. They were designed to handle cases when the return type may or may not contain your value. So let's do all of this using optionals, and you'll see that we will significantly shorten this code. I know it's already not very big, but you can imagine we could have loads of we could do if superhero by name dot get name, but what if it didn't have a name? There's loads of things where we can check for null or not, right? So let's have a look. And what we're going to start by doing is we're going to change our service layer, so our service method that calls our database, to return an optional of a superhero. So remember, this is just searching by name. We can't guarantee that we have your superhero in our database. So let's change this to return an optional of superhero. Just like that, okay? And obviously this is now going to complain because all we need to do now is wrap this inside an optional. Now, remember how I said optional.of is what we use when we know that there's a value in the optional? Well, there's another one I haven't shown you yet. And this optional utility method will accept an empty value as well. And that is optional of nullable. So optional of nullable is basically where this either exists or it doesn't. This will probably be the most common type of optional you will use because this is literally, it either contains the value or it doesn't. And it doesn't actually know, right? Because this is calling a external class and getting the value back. So we can't guarantee that this is going to find our superhero. So as you can see, this is now going to be complaining, right? So let's change this to an optional of superhero, okay? And let's comment this out just so we have it for reference. And maybe let's just create some space. So now we know that our method returns an optional of superhero, of Ant-Man. Okay. Now, following this example, something similar that we can write, which is a good starting point to show you some of the utility methods that an optional has, is we would probably do if superhero by name. Maybe let's rename this and let's do code occurrences, and let's just add the word optional at the end, just so we're clear that this variable is not the superhero, it's actually the optional of the superhero, right? So one of the methods that you're likely to use is the isPresent, right? Now isPresent basically does what this does, where it checks if it's not null. So if Ant-Man did come back from our database, isPresent would return true. If it didn't, it would return false. And if you had a keen eye there, you'd probably also see we've got isEmpty, okay? And isEmpty is the exact opposite. In this scenario, we're checking if it does not contain it. But let's use isPresent. And we can actually pretty much copy what we did here. And it would work exactly the same, I believe. So let's check this out. And if it's present, if you remember that method I told you that you can use to unwrap an optional, you could use that here. Let's use get. Okay. Now, my advice was never to use this method. Okay. And we'll touch on that in just a second. But let's run this. And as you can see, we got superhero does not exist. Okay. So this actually doesn't really help us in terms of it kind of looks exactly the same, right? It's a bit more readable because we're now adding kind of more English language. We're saying, is it present? Then do this, otherwise do this. But it's kind of the same length. Let's see what else we can do. So I told you not to use the .get method, and that is this one, okay? But there is another one that does the exact same thing that you might want to use. So let's delete this and let's get our printing method over here, right? Let's do a sout. If we typed in our optional and did a method called or else, what this does is it will either print out, because we're doing it in a print, it will either return the value of the optional, so it will basically do the .get, or it will do something else. So if I type in here now, superhero does not exist, let's copy that from here and chuck that in there. And I think we have, oh right, yes, this expects a superhero, so maybe we can provide it a default superhero. So maybe we can print new superhero, the name can be default. Oh, let's chuck this on a new line just so you guys can see. Default and default. Something like this, right? So what this is saying is if there's a superhero in here, print that out. Otherwise, print this superhero out, okay? And at the end of this, we can do our toString, like just if we wanted to, right? And now let's run this. And there you go. Because Ant-Man doesn't exist, it's used our alternative. So this way, we will never hit a null issue, right? Because there is nothing, there is something that's catching a scenario when it doesn't exist. And if we stick Spider-Man back in here, let's have a look at what happens. There we go. We've got Spider-Man back. Okay. Now that is just one of the cool methods that are part of optionals. I think we can delete this now. Let's have a look at other things that work similarly. So we can also do superhero dot or else throw. Now or else throw will either print out a superhero or it will throw an exception for you. So this will throw a no such element exception. So this is a case where it's already handled the situation where it doesn't exist. Normally you would write an if this exists, print this, or else, and inside your else you will do throw new exception, blah, 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 just like that, right? And if we change this back to Ant-Man and we run this, notice here we've got a no value is present and we've got our no such element exception. And if we change that back to Spider-Man and we run this, realize this is a bit big. And we got two sets of Spider-Man because it's hitting both methods, right? And as you can see, that's just in one line, we've kind of handled an if-else situation. Okay, there's plenty more of us to go through. Let's go through them quite quickly. Now, optionals are an example of functional programming. So functional programming is essentially where we are using mathematical kind of expressions, or we're trying to avoid storing state so we can kind of do things on the fly. And I'm going to show you an example that we can do that. Literally, we're going to do exactly what we've done using functional programming, using optionals. So let's add some space just so you can see clearly what's going on. So let's say we wanted to do exactly the same thing where we either have a superhero or we do something else. But what we can do is we can take the superhero optional like this. In fact, let's change the name of this just so it's a little bit shorter. Superhero optional, okay? And let's take the superhero optional, and like before we did the is present, there's also a if present, okay? And this takes in a consumer or a lambda expression, for example. So let's say it takes something like this, okay? And what we can do here is print, let's pass in, let's just do hero, okay? And we can print the value of the hero like this, okay? Now directly we are doing in one line the whole is present, then do this and that. So let's run this. There you go. There's the third one in the list there, right? I'm actually going to comment this one out. And the reason why is I don't want us to be running this and it throws an exception before it gets to our line. Okay, so I'm going to comment this one out just so you guys still have it for reference. And if you notice here, IntelliJ is giving us a bit of a more cleaner way of doing exactly what we've done, where we can use method references. So this is literally the equivalent of this lambda expression over here. Okay, so let's go ahead and use IntelliJ's quick solution, right? So this line here, only if the superhero is present, so only if Spider-Man's come back, will it print it to the system. So you can see we've completely bypassed needing an if or else statement here. Okay, so let's have a look at what else there is. We've got if present or else. Now this is one of my favorites. Okay, so what this does is it does the exact same thing as above. So let's see if we can, system dot out print line. Okay, so it's done exactly what it's done up here. And then let's add a comma. And it also takes a runnable. So it takes our consumer and another runnable. Now what this one does, this is the case that it could not find our superhero. Okay, so let's just do a print out and write superhero not found. Okay, just like that. Okay, I'm going to chuck that on a new line just so it's readable for you guys. And I'll add some space here. So this is saying if you found the superhero, print it out. Otherwise, so in the or else, which is the second argument, which is this, print out superhero not found. Okay, let's run that. So obviously in our current situation, we're most likely going to get the superhero out, right? So let's change this to, or let's comment the rest of these out, just so we can really focus on this one alone. So let's change this to ant and print this. And there you go, look, we've got a message that says superhero not found. Okay, obviously my text size is quite big, so but you could squeeze this on one line. It's just obviously for you guys, I want you guys to be able to see it clearly, but you can really see how quick functional programming is to kind of just get going with it, and how little lines of code we are writing to do exactly the same stuff. Okay, so there's another method that you've been introduced to with optionals. Let's have a look at what else there is. So we've got if present or else, which we've just used. We've used is present, we've used if present. There is loads of different ones. We've got flat map and we've got map, and map's quite an interesting one. So let's have a look at what map does. It takes in a function. So let's just take in hero, okay? And we can actually do superhero, let's just do hero dot get name. Okay, now what this is doing, this is taking our optional and extracting the name out of it, and what this will actually do is create an optional of string for the name. So let's replace this with the method reference. So now if we do dot get, I know I said not to do this, so please don't do this, but let's change this back to Spider-Man, and let's print this out. So I'm just doing this for demonstration purposes. Let's comment that out and run this. See, we've got just Spider-Man, because what this has done, so our superhero optional, we're mapping it, so if there is something in here, we're getting the name outputted out of it, right, as a string, but this is as an optional of the string. So if you hover over this, we can change this to, if present, do something. So let's do name, print name. So actually now we can get rid of what we were doing before. I think I am missing a bracket there, and let's do this on a separate line, and let's replace this with the method reference. We don't need this. There we go, and we can do a or else print no name found, just like that. And I think we're missing a bracket. There you go. So what this is doing is we're checking if the superhero optional has anything in it. If it does, we're extracting the name property from that superhero as an optional of string, because that is what type the name is. And if there is a name, we're going to print out the name. If there isn't, we're going to say no name found. Because obviously at this point that means the superhero exists. But what if the superhero did not have a name? Maybe the name was null. And we still got Spider-Man. But let's see if let's do Ant-Man again. And you'll see that it should just do nothing. Oh, we got no name found. Right, yeah. So that is the fallback. Okay, so this is the or else. If it's not present, no name found. Or we can do no superhero found. Okay, that makes a bit more sense. So now we've met what the map method does. Okay, so let's comment that out, and you guys have that for reference. So I've just cleaned up some of that code. Now I'm going to show you another method, which is the or else get. So let's do superhero optional dot or else get. Now what this does, this takes in another supplier, or this is basically, we can call another method to call something else. So what I've actually done is I've created another method here called default superhero. So let's say Ant-Man doesn't exist, we want it to do something else, maybe we want it to call the database again, but let's say for this instant we just want to call the default superhero method. Okay, and let's just replace that with the method reference, and let's do printing this statement out just like this, and let's run this and see what that behaves. And there you go, we got our default back. So the or else get will allow you to call another method in case this optional did not work, and you see that it's expecting a superhero back. So you can call any other method that gets back a superhero. Okay, you could even have called this back and maybe done some more code to get, maybe you have Spider-Man as your default hero, for example. So that's another use of the optional. We've also met or else, we've met or else throw, so these are just variations on the same one. And you've also got an or, which basically you can say if this optional did not exist, similar to this, we can call a method again. So let's do a lambda function here, and let's do find superhero by name, and this time we do Spider-Man. Okay, and this will return an optional. So if we did .var at the end, you can see that this creates an optional superhero and we can call this optional superhero as you like. And if we printed this out, let's just undo that and just print this out. Oops, delete that, close the bracket there and delete this and print this out. You'll see in the second scenario here, we got Spider-Man back. Right? Because we're saying if you did not find the superhero by name, instead call this method, and that returned an optional. As you can see, it's wrapped outside an optional. So then we can do the whole, if present, then do this, or etc. In fact, if we did chain it with the is present, we don't need the print, because this is what functional programming is about, right? So we can do things kind of on the fly. So if present, we can actually just say Let's do hero again, and we can do a lambda method here and just do print hero. And as you guys have seen now, IntelliJ will give you the method reference suggestion just like that. So now if you run this, we no longer get it wrapped inside an optional. There are so many methods available to you, and these are some great ways to avoid having null plastered all around your code. The key thing here is do not overuse optionals. Remember what they were designed for. They were designed to cater for these kind of scenarios here where you're not guaranteed a response, or if something is literally optional, right? So we're not guaranteed to find a superhero based on the user input, because the user input could be a bunch of garbage, right? Never trust the user, basically, is what I'm trying to get at. And this is just a more elegant kind of solution to handling the scenario and making it a little bit more readable. So I hope you've learned something today with optionals, and if you had any questions, chuck them in the comment section below, and don't forget to give this video a thumbs up if you enjoyed it, and subscribe to my channel. Thank you very much for watching, and have a great day and happy programming.